right, my friends, let's start by taking a look at the integral from -2 to 0 of 1 over x dx. I personally think that the most empowering way to think about these things is graphically. So I'm just going to look at the graph of 1 over x. I'm just going to do a quick little sketch of the part of the graph that would really matter here. So you can see you've got an integral that starts at 0 and stops at 2. And then the bounded region is not so bounded. I keep saying bounded region. I don't know how to, should probably look up the correct vocab for this. Anyway, but you can see that you have kind of this asymptotic behavior where your graph is approaching the y-axis, but your graph is, does not appear to be bounded there. So watch out for horizontal asymptotes, which we had earlier, and also vertical asymptotes in your like between your limits or your bounds. And that's basically what's so improper about it. So for this integral, it's the 0 essentially that's so improper. So if you were asked to evaluate this, you could, write it like this. So the limit as your upper bound approaches 0. And which side would we be approaching 0 from? Look at the graph here. We would be approaching 0 from the right. And then you could do from -2 to b of 1 over x dx. And we're not going to finish that, but I did want to at least show what's so improper about it and then kind of what to do about it to get started on a problem like that. Okay. Now let's look at the integral from 0 to 2 of 1 over x minus 1. And again, I do think that you will be most empowered if you can just think graphically about something like this. So let's look at the graph of 1 over x minus 1. That's just a 1 over x graph that got shifted to the right one. So it has a vertical asymptote at x equals 1. And then it basically looks something like this. So here's 0, and then here's 2, and then this is the region that we're supposedly finding, evaluating the area for. And so what's so improper about this integral? Well, I claim it would be x equals 1 that's improper. Notice that it's not either of the bounds this time. It's a value like between the bounds that would make this integral improper. And so, so the way to fix this would be to break this into 2 integrals. So break this one improper integral into 2 improper integrals. You could do the integral from 0 to 1 over x minus 1 dx plus the integral from 1 to 2 of 1 over x minus 1 dx. And then from there, kind of decide, well, from which side are you approaching 1 for this first integral? And so I hope it makes sense to be approaching 1 from the left side for that first integral. So then that would equal the limit as b approaches 1 from the left of the integral from 0 to b over 1 over x minus 1 dx. Plus, and then for the second integral, you'd be approaching 1 from the right. And so you could fix that by taking the limit as a approaches 1 from the right of the integral from a to 2 of 1 over x minus 1 dx. There we go. Okay. And then, at that point, you just follow your nose and grunge it out using the techniques that we've been using all along. So I wouldn't be teaching you anything new beyond this, but I did want to make sure that you're okay with, vertical asymptotes being as improper as horizontal asymptotes if they're between the values of your bounds. And then the sneaky one here, where you'd have vertical asymptote not at either of your bounds, but in between them. And then how to kind of make your rewrite your integral as you approach that vertical asymptote from one side or the other as appropriate. So there you go. That's that. That's what I have to say about that. All right, my friends, with that said, let's have you take a look at example 5, see if you can evaluate each integral, and do your best. Check in with me in the next video.